Welcome to Spring LIB.
So in this problem, we are given a mixture which contains KClO3, K2CO3, KHCO3, and KCl, and which, when heated, they produce CO2O2 and H2O according to these following equations. And the KCl that does not react under the condition of this reaction. So you're asked if we are provided with 100 gram of the mixture, and if they produce 1.8 gram H2O, 13.2 grams CO2, and 4 gram O2. We have to find out the composition of the original mixture. That means we have to find out um, which of uh, these compounds contain what mass in grams in the original mixture. So to find out the mass of each of these compounds or reactants, what we have to do, we have to use the products or the mass of this water, um, CO2 and O2, and using these masses we can find out the mass of these uh, compounds in the mixture. So from here you can see that oxygen is produced only from KClO3, so we don't have any oxygen in any other two of the reactions. That means from the mass of oxygen, what we can do, we can find the number of moles of oxygen which is being produced here, and from there we can find the mass of, we can find the number of moles of KClO3 which is reacting, and from there we can find the mass of KClO3 which is reacting. And similarly, we can see that CO2 is being produced from both K2CO3 and KHCO3. So what we can do is, first we can use the mass of H2O, which is only being produced from KHCO3. So from the mass of H2O produced, we can find the number of moles of H2O produced. And since the H2O is produced from only KHCO3, we can use the number of moles of H2O to find the number of moles of KHCO3, which is reacting. And from there, we can find the mass of KHCO3. Then from the number of moles of KHCO3, we can find the number of moles of CO2 and the mass of CO2 which is being produced from KHCO3 only. And then um, from the mass of CO2 which is being produced from KHCO3, then we can find out the mass of CO2 which is being produced from K2CO3. Since we are given the total mass of CO2 here, we can just subtract the mass of CO2 which is being produced from KHCO3 from the total mass of CO2, and we can find the CO2 which being produced from K2CO3. And from there we can find the number of moles of CO2 being produced from K2CO3, and from there we can find the number of moles of K2CO3 which reacting, and from there you can find the mass of K2CO3. And this way we can find the mass of all these three, and then just subtracting the sum of all these three from the total mass of 100 gram, we can find the mass of KCl which is contained in the mixture. So let's start first by finding out the mass of KClO3. So to do that, what we'll do, we'll first find the number of moles of O2. So the number of moles of O2 being produced is the mass of O2, which is 4 gram. We have 4 gram O2 being produced. So we'll place the mass of O2 being produced over its molar mass, which is 32 gram per mole. And from here, we can find the value of number of moles of O2, which will be 0.125 mole. Now we can find so from here we can find the number of moles of KClO3 which is reacting. So from here, from the balanced equation, we can see that 2 mole of KClO3 is reacting with 3 mole of O2. So we can write 3 mole O2 is identical to 2 mole um, KClO3. That means 0.125 mole O2 will be identical to 2 over 3 times 0.125 mole, which will give us a value of 0.083 mole. So this is the number of mole of KClO3 which is reacting. So from here we can find the mass of KClO3 by simply multiplying this number of mole of KClO3 by the molar mass of KClO3, which is 122.6 gram per mole, and this will give us a value of um, 10.21 gram KClO3. So this is the mass of KClO3 which is present in the mixture. So we have got the mass of KClO3. Now we will find out the mass of KHCO3. For that we will utilize the mass of H2O, and from there we'll find the number of moles of H2O. So number of moles of H2O will be the mass of H2O, which is 1.80 gram over the molar mass of H2O, which is 18.016 gram per mole, and will give us a value of 0.100 mole. Now from the balanced equation we can see that 1 mole H2O is produced from 2 mole of KHCO3. That means 1 mole H2O is identical to 2 mole KHCO3. That means 0.100 mole H2O will be identical to 2 times 0.100 mole, which is equal to 0.200 mole. So this is the number of mole of KHCO3 which is reacting, and from here we can find the mass of KHCO3 reacting by simply multiplying the number of moles of KHCO3 by its molar mass, which is 100.1 gram per mole, and this will give us a value of 20.02 gram KHCO3. So this is the mass of KHCO3 which is present in the mixture. So we have got mass of KClO3 and KCO3. Now we'll find the mass of K2CO3, and to do that, what we would do is we'll first find out the mass of CO2 which is being produced from KHCO3, and from there we'll subtract this mass from the total mass of CO2 to find the mass of CO2 which is being produced from K2CO3. So um, so how we will find the mass of CO2 being produced from KHCO3? What we'll do is we can see that 2 mole of KHCO3 can produce 2 mole of CO2. That means this much mole of KHCO3 will produce the same number of mole of CO2. That means we can write number of moles of CO2 is same as this, which is 0.200 mole. That means the mass of CO2 which is being produced from KHCO3 will be the number of mole of CO2 being produced from KHCO3 times the molar mass of CO2, which is 44.01 gram per mole, and it will give us a value of 8.802 gram. So this is the mass of CO2 which is being produced from KHCO3. Now we can find the mass of CO2 which is being produced from K2CO3. So the total mass of CO2 is being produced is 13.2. So that means MCO2 produced from um, K2CO3 will be equal to the total mass of CO2, which is 13.20 gram, minus the CO2 produced from KHCO3, which is 8.802 gram, and this will give us a value of 4.398 gram. So this is the mass of CO2 which is being produced from K2CO3. Now we'll find the number of moles of this CO2 which is being produced from K2CO3. So NCO2 from K2CO3 will be the mass of CO2 being produced from K2CO3, which is 4.398 gram over the molar mass of CO2, which is 44.01 gram per mole, and this will give us a value of 0.100 mole. So this is the number of mole of CO2 which is being produced from K2CO3. Now from here you can see that 1 mole of CO2 is being produced from 1 mole of K2CO3. That means this much mole of CO2 will be produced from the same number of mole of K2CO3. That means the number of mole of K2CO3 is also 0.100 mole. That means the mass of K2CO3 which is present in the mixture will be its number of mole times the molar mass, which is 138.2 gram per mole, and it will give us a value of 13.81 gram K2CO3. So this is the mass of K2CO3 in the original mixture. Now we have got KClO3 mass, we have got KHCO3 mass, and we have got K2CO3 mass. So now we can find the mass of KCl, which will be the total or the original mass of the original mixture minus the total of the other reactants which we just calculated. So the mass of them will be 10.21 gram plus 20.02 gram plus 13.81 gram. So mass of KCl from here will be 55.96 gram. So this is the mass of KCl. So now we can write down the composition of the original mixture, that is mass of KClO3 is 10.21 gram, mass of KHCO3 is 20.02 gram, then mass of K2CO3 is 13.81 gram, and finally mass of KCl is 55.96 gram. So this is the composition of the original mixture.